In this problem, we are given the following circuit diagram. We need to assume the op amp is ideal, and then we can use this to determine the current IL. When we look at this, if it's ideal, our op amp is ideal, we know two things. One is that there is no current flowing into our op amp. Two is that the voltage for this negative part, which is the inverted part, and the voltage for the positive part, the non-inverted part, is equal to each other. So if we take this node right here and we say this is Vn for negative and this is Vp for positive, that our V of n is equal to our Vp. So when we do this, we can use node voltage analysis. And we can use the node voltage analysis to find the output voltage from our op amp. If we find the output voltage, we can put our voltage over the 5 kilo ohm resistor and use Ohm's law to find our current. So we're going to start this off. Instead of using Vn and Vp for our different formulas and using them interchangeably, we're just going to set this equal to a V1. That way we can combine them and see them a little bit easier. So when I look at this first, I see that we have 24 volts over this 30 kilo ohm resistor that is a part of our Vn node voltage. So we know we're going to have a Vn, right? And we know the voltage is going into the positive out of the negative. So it's really going like this. So we're just going to have a minus 24 volts. We're going to have Vn minus our source voltage. And this is all happening over the 30 kilo ohm resistor. Next, we have a plus, and this is going to be the second part, where since we have an inverted amplifier, we know that after our output voltage, some of that output voltage is going to go back this way and into our op amp. And this is called negative feedback. So due to this negative feedback, we know we have some voltage coming across this 20 kilo ohm resistor across our Vn right here. So that's why we need a plus Vn, and then we'll just call this voltage, the output voltage, VL, to match our I of L. So our output voltage is going to be V of L, and we're going to have a minus V of L, and this is all happening over our 20 kilo ohm resistor. Now we're going to set this equal to 0. From here, we're just going to simplify a couple things. So what I'm going to do is multiply the top and bottom. So I'm going to just multiply everything by 10 kilo ohms. That'll get rid of the 0 and the kilo ohms for both of these. And now to completely get rid of the denominator, I'll multiply everything by 6. So if we do this, we are going to get a 2 Vn minus a 48 volts. And I just realized that I did not convert the V's, the Vn's to 1. So this should be a negative 2 Vn minus 48 volts plus 3 Vn, and this should be 3 V1 again, minus 3 V of L, and that's all equal to 0. Now that we have this, we can combine a few things. First off, we want to solve for V of L. We know that we want to solve for V of L. So I'm going to combine the V1s. This is going to give us a 5 V1 minus 48 volts. And if we move our VL to the other side and divide it by 3, we're going to have over 3 equal to VL. So this is our equation. This is the equation that we are going to be, once we find our V1, plug it back into here for. So now we look for our V1. We're looking at this VP part. We know our voltage, we have some going like this. So we are going to have VP, and the current, or the arrow I just drew, is not the actual direction of the voltage. I'm just showing the relation of our VP into this 12 volt voltage. So we have VP minus 12 volts, and this is all happening over the 6 kilo ohm resistor. We have a plus because we have this 18 kilo ohm resistor that our VP is also over. So we have a plus VP over 18 kilo ohms, and this is all equal to 0. Now to simplify this, we are going to multiply everything by 18 kilo ohms. We are going to get 3 VP minus 36 volts plus VP, because the 18 kilo ohms is going to cancel out. We can add our VPs together, and remember the VP is supposed to be V1. So if we do this, we're going to get 4 V1 and move the 36 volts over is equal to 36 volts. So we know that V1 is equal to 9 volts. We can plug this back into our original equation. If we plug 9 into here, we are going to get 5 times 9, which is 45, minus 48. That'll give us a negative 3. Over 3 will give us a negative 1. So we know negative 1 is equal to our VL. So we found the voltage for our output. Now we're going to use Ohm's law to find the current. We know I of L is equal to, and when we plug this into a calculator, we know that 1K is equal to 1,000. So we're going to have 1 divided by 5 divided by 1,000. And this is going to give us this answer. So this will be 2 times 10 to the negative 4. We want our answer to be in microamps. To convert this, we'll have 1 micro, and that's over 10 to the negative 6th. Well, we'll get rid of this, and we will make this a 10 to the negative 2. If we do this, we can flip this on the top, and then we're going to get a 10 squared. 2 times 10 squared is that I is equal to 200 amps. I'm sorry, microamps. And this is our answer, 200 microamps. That's how you do this problem. If you have any questions about the material we covered, you can leave them in the comments below. If you want more introduction to circuit analysis, there's in the description a playlist full of these problems and notes as well.